Hello and welcome back to Azure Terraformer. Today we're going to continue our journey with some of the basics, what I'd call meat and potatoes of using Terraform to manage Entra ID. We've already gone over how to create users and groups and to grant these entities permissions within Azure. We also had a little bit of fun using ChatGPT to generate an extract of data that allowed us to simulate a bulk user import. So we've explored both stateful and stateless scenarios with which we can use Terraform. And that's one of the cool things about Terraform is it's very much a choose your own adventure. If you want to use Terraform state and manage long-term, you can. If you just want to use Terraform to shotgun something into the cloud, you can. And there's valid use cases for each method. Today I want to drop into a method for managing Entra ID that I think is very useful for state management long-term. And that's managing a group and members of that group. Just like with traditional software development, wrapping a Git flow process around your software team gives you some innate benefits. It gives you an audit trail of all the changes that were ever made to your code and configuration. It gives you the opportunity to create a review process for certain authorities on your team to verify, validate, and approve changes to your application and to your configuration. Well, the same benefits can be used when managing Microsoft Entra ID. And taking it even a step further, we could even implement GitOps to have this process fully automated to grant users within our environment the necessary permissions that they need within Azure and to have the authorized parties conduct the appropriate review and approvals. Then if there's any question to who has access to what and when they had access to it, all you have to do is go check your commit history on Git. Anyways, without further ado, let's drop into code and make this happen. So I'm going to start off with my standard template. I've got Azure RM and Azure AD loaded here. I'm definitely going to be using Azure AD to provision groups and group membership resources. I may need to use some data sources to pull Azure AD users or Entra ID users. And then I might grant some permissions on Azure using the Azure RM provider role assignment resource. If you've been following any of my other Entra ID videos, you'll be familiar with this setup. So let's start by setting up our group. For a simple use case, let's create a group for our subscription admins and then a group for our subscription readers. I mean, these are two common scenarios that you want to grant access to. Of course, in a real world environment, there's going to be lots of shades of gray here. You might have another group for people that just need access to the billing information of a subscription. You might have other operator roles that have much less permissions than what we're going to grant the admins today, contributors. Maybe you have, some support staff that can perform some basic operations on virtual machines or something like that, or access storage accounts or something. Now the owner is going to be the current user. And of course I am going to be using the Azure AD client config, current user. And I am pulling the Azure RM subscription here. Of course, as you might recall, this is going to be used to pull the subscription ID for when I create role assignments. Now, I do want to have, we'll call this subscription admins. It's not a great name. And then we'll have subscription readers. Now, I'd probably, in a real world scenario, I'd probably give this like maybe a little bit more detail about like what subscription, maybe this is going to be for an application app foo dev subscription readers, and then app foo dev subscription admins. So if you've got an application called foo, I mean, we'll just call it like this. You might have a naming convention for this group where you set up the application name, you set up the environment, and then you have the role names. So foo dev readers, foo dev admins, I'm foo being my application. I think in 2024, I'm going to start some adventures where we do some full stack development. So I won't have to use these anonymous monikers like foo. And we'll actually get to use a real application name, but more to come on that. Okay, so now that I have this group admins and readers, let's go look at how we can create group members. And there we go. It's a lot of the Terraform documentation has the top level or the most important proper nouns. Those are nouns with a cap that are usually capitalized. That's how you know you're dealing with a proper noun. Kind of an important entity type within the provider. They are grouped under that proper noun, and then related types are nested within there. So group member is one of those types, and group member is a great example of one of these little connector resources. Back when I first started software development, I did like schema design, database schema design using SQL Server and things like that. This kind of reminds me of like those relationship tables, you know, where you've got two tables, A and B, and you need to have a relationship between them. And so you create a little table that has the foreign key to table A and a foreign key to table B, and it kind of connects, you know, the two tables together. So that's, you see quite a few of these little resources, you know, within the different providers, Azure RM, AWS, Azure AD, of course. So it's a pretty common pattern. And so here I'm going to create a readers and a corresponding readers and a corresponding admin member group. Okay. Now you might be wondering, like, well, what the heck, Mark? Like, are we just going to have one member? Do I just copy pasta this resource block every time for every member that I want to add to this group? And yeah, you could do that. Or, you know, you could create a list and iterate across that list. Or create a map and iterate across that map. Easy peasy. So to keep this simple, let's kind of split this file. And this is one of the really nice things about Terraform, is because it's working directory based, and this is different from Bicep, right, where it's entry point file based. With Terraform, because it's working directory based, I can move resources around very easily and reorganize them across multiple files, and I don't really have to worry about the taxonomy of the file system and how that interplays with the resources I'm declaring. As long as they're in the same folder, we're good. So I'm gonna go ahead and call a new file called groupadmin.tf, and just because I have, you know, limited mental capacity, I'm gonna split these each into their own file so that when I'm looking at the group admin, I only see the stuff related to group admin and I don't get all confused, you know, because I get confused easy. So now I'm gonna create group reader.tf. There we go. And there we are. So I've got group admins, and then I've got a group member for admins, and I need to make sure that these references are correct. So this is referencing this resource here. It's going to be the same name. Again, that's a naming convention that I'd recommend if you have, because Terraform uses type-based naming. The resource type is kind of the prefix of the name of your object. A good way to correlate related resources is to just use the same object name across all those related resources. And then it makes it very easy to find resources of different types that are all related to the same construct that you're trying to automate. So in this case, I've got admins group member, and I've got admins Azure AD group. And so now I need a member object ID. Now, what is this? An object ID in Microsoft Entra ID is going to be a GUID. If I really want to go down to the most primitive context here, I can go access the object ID from my user account, or in this case, we'll just pull a Kaiser. So here's old Kaiser here, right? And right front and center, I've got Kaiser's object ID right here. So if I wanted to, I could just hard code this member object ID with this GUID. And I know, and you know, that 1 Bravo Bravo 48870 is Kaiser Soze, but it's not the greatest user experience, right? Am I right? I mean, if you come back and look at this later as a future author yourself or somebody else, you're gonna be like, oh yeah, I know 1 Bravo Bravo 48870. No, you're not. Nobody's going to do that. Okay. Maybe Rain Man's going to do that, but I guarantee you this is not a good look. Yeah. So we'll fix this here in a second. I just want to peel this onion a little bit slower so we can see what the heck's going on. So I'm pretty happy with this right now. Let's just run this and see what we get. So it's always good to go look at your plan. Oh, member object ID 1 Bravo Bravo 48870. Yeah, I know that guy. Good guy. So we got 2 groups, readers and admins. And oh, look, the owner is 43072 Charlie Foxtrot 2. Yeah, I know that guy too. Real nice guy. Anyways, you'll get my point here in a second. Okay, so that's been provisioned. Let's go check out what we got now. All right, there we go. So we got foo dev readers and foo dev admins. And if we go interrogate this group, we can look at members. Okay. And there's the member and there's the owner. So what we didn't pick up from the plan was who the heck this guy is, right? I think if we go back and look at that plan, 43072 Charlie Foxtrot 2 is me, right? And then Kaiser is 1 Bravo Bravo 48870. So Azure Active Directory, Microsoft Entra ID, they use a lot of GUIDs as unique identifiers for entities. But that doesn't mean that our infrastructure as code needs to use those GUIDs, okay? In Terraform, we have a nice way of looking up things with human readable context. So we don't have to rely on these GUIDs. So definitely do not use these GUIDs, okay? It's a bad look, okay? So for starters, I'm going to go ahead and reorganize this a little bit. I'm going to extract the administrator members and the reader members as input variables, basically just as a list, right? And the reason why I'm going to do that as a list is because it's easier to maintain a list in the input variables.
A few moments later.
And so now I could go through here and I could say, okay, count is the length of var dot, I'm in readers, right? And then I can go grab the item out of var reader users, count.index, and we could be super happy, right? And we could do the same thing here. And I think it's kind of mad. It's kind of mad because I left this blank, like it's not working. Okay. And so basically what have I done? I have declared 2 list input variables, one that contains a list of admin user IDs and another that creates a list of reader user IDs. I've provided that list of users in list format in the terraform.tfvars file. And I have modified the group member resource to use the count meta argument and key off of the length of my admin users, and for each item in that list to go grab the correct item at the correlating count.index in order to create a member for each GUID in my list. So this is pretty much going to do exactly what I did before, but we're going to see a little bit of churn when I try and run this apply, because we're changing the plurality of the group member resource. So we're going to have to destroy the old stuff. Oh, and actually we're not really doing a lot of churn. It's actually picked up on that these are logically equivalent, but it just needs to move, the single item that used to be there to a new item at index 0. So it's actually done a better job than I expected, because I was kind of expecting it would have to drop create, but it looks like we're just moving it from a different location within our state file. And nothing added, nothing changed, nothing destroyed. Now, let's go add myself to this members list, and let's go see what happens. So I am the owner of this group, but I am not a member. So we should probably add me as a member. Now let's try this again. Now you can see that because I've changed the list, I've actually inserted a new user, me, at the beginning of this list. That shifts all of the users down in this list. This is very common gripe against the count meta argument, in that it creates churn whenever you want to do this. Now, this is not a huge deal because there's not a lot of dependencies based on the memberships here. But if I had cascading dependencies on these resources existing, I wouldn't really feel great about having this churn happen, because it could break things as these things get added and removed. Now, there are some resources that you can tolerate that churn, given that it's not a significant amount of effort to just change this to use a for each. You might as well do that. So you can see here that we are changing the first index from 1 Bravo Bravo to 43072. And then we're adding a new one at index 1 with the 1 Bravo Bravo, right? So basically just shifting the list all down. Now, if I had 10 users on this list and I did an insert at the top, I'm going to have massive problems, right? Because it's actually going to replace all of them down the line, and then add a new one at the very end, right? So it's not a great look, but it does work, right? So you can see I am destroying 1 Bravo Bravo from index 0, and then we're also creating 1 Bravo Bravo at index 1, and there we go. So now if I go look at this group, but there we go, I got 2 members now. What could we do to make this a little bit better? Well, number one, I don't want to go create a map here because a map kind of needs a key value pair. Now, I suppose I could try this and just set this up like that, but you can see it's kind of mad, right? Like it's going to want me to put something in this map to say, to have a value there, right? So now this is a valid map, and I could iterate across that, but it's kind of goofy, right? Like, is this how people think of, like, is this how people think about this? Like, I don't know. Like, I guess I could put some placeholder data there, but it seems like an unnatural way to store a list as a map, right? Just for the sake of fulfilling Terraform's needs, right? So I think probably a better choice would be to leave it as a list, but then just to convert the list into a map within Terraform. That way, whoever's maintaining the TFRs file, the complexity of this improved operational state of using the map to for each across such that we can avoid churn is abstracted from them. They don't have to worry about it. Like they can maintain a list and they can be happy with it. And maintaining a list is probably easier on the operator than maintaining a map. Now, the problem is we need to convert a list into a map, right? So here's a good little tip. ChatGPT, if you don't know how to do this, ChatGPT is a really great resource for basic HCL. It's not super great for Terraform in general, but you can basically ask it simple transformation questions, like take this and convert it into a map, and it'll create the HCL code pretty easily for you. So let's go do that. So I have this list in HCL, and I want to convert it into a map. So I can use for each to iterate across it in Terraform. Now, this is a pretty great answer. And this is, I think, a place where ChatGPT really shines. If you give it a very focused problem, if you give it good sample data and you give it clear instructions of what your expected output is, in this case, it's pretty simple, right? I'm just taking a list and making it into a map. It gives you a pretty nice for each block here. So now it is assuming it doesn't know the full context. It doesn't know that that's actually an input variable. So it's kind of inferring some things here. I can kind of massage this code in there as long as I know what I'm doing, right? I know that admin users is an input variable. It's not a local, so I can just ignore all this. What I do need to do is I need to grab this for expression and jam it into a local. So let's do that in the appropriate location. So I think it makes sense to do it in the group, in the file that the group is declared in. So let's just jam that in there. Not a huge fan of, the map. Technically, this is a local and the input variable is a list. So here we have, I'm taking my naming, my correlating naming convention a little bit like strict here. So I have an input variable called admin users that's related to a local variable called admin users. This could get a little confusing, but they are extremely related, right? And so what I'm doing is for user, and again, it's telling a story. This follows my best practices in writing for expressions. for each user in admin users, create a map that just does user to user, right? And so now I can change this from, instead of count, I can just say for each, and then I don't have to do the length thing anymore. I need to use the local, not the var. And now instead of this, I just need to go each.key, because if you look at the for expression, the key and the value are the same, right? So again, this implementation complexity really doesn't matter, right, to me. You know, if I'm just maintaining this list of users over here, but it does simplify the operational overhead of maintaining this group of admin users, so that I don't have kind of erroneous data, right? I have a nice clean list, and then the HCL can do kind of the legwork to get this into a nice clean format to eliminate churn, right? So let's try this, and let me back out my user ID from this collection, so that we can really see, kind of have the same experience. So it's probably going to do, I'm not quite sure what it's going to do, because right now, if you recall, we had the count meta argument, and now we're converting it to a map. So yeah, it looks like it's just going to destroy all the things and then add back in, because we're moving from a count to a for each meta operator. So here we go. Yes, we're going to delete all the things. And now when I insert my user ID into this list and run reapply, we're not going to have that churn. It's just going to know, okay, one Bravo Bravo is already there. I can go add Mark in there, right? Okay, before we go nuts here, let's just go check this group and make sure it's got the right members. We should only see one member. Yep, Kaiser. Okay. So now let's go add myself back in there. And now let's look at what this plan looks like. So because I'm using for each, I'm taking the list, converting it to a map. The iterator is iterating across that map. And so it should know that Kaiser already is there. We don't need to go add Kaiser, but we do need to go add Mark. And even though Mark is at the top of the list, we don't have to shift people down because we're not using the count meta argument, right? So there we go. Wonderful. So now let's do the same thing for your reader users, and we should be off to the races. And we can see that again, we are drop creating because we're transitioning from the count to the for each meta argument. Okay, now let's go check out what we've created here. Let's smash refresh. Now admins should have 2 users or 2 members, right? There we go. And then our readers should have 1 member, just Kaiser, right? And so now if I go and add myself to the readers group, just like I did to the admin group, I should see that I'm not going to actually impact Kaiser. It's not going to like drop, create, replace, do any kind of crazy stuff. It's just going to know that Kaiser's already in that group, so we don't have to do anything, but Mark needs to be added. And there we go, 1 to add, that's it, and that's me. So there we go. I hope you found this helpful. We started by creating an Azure Active Directory group or an Entra ID group and adding members to that group, but we also exercised 2 key concepts in HCL. 1, the idea of iterating using a for each to avoid churn and unnecessary drop creates. And then 2, the idea of leveraging a simple input parameter type to make it easier on operators maintaining that list in the TFRs file or elsewhere, and converting it to a map inside your project to encapsulate that complexity from the end user that's maintaining the configuration. So you really get the best of both worlds. You get to maintain the group's members as a list, which is simpler than a map, but you don't have the churn of using the count meta argument to iterate across it. This is a strategy that I use to try and balance maintainability aspect of an infrastructure as code solution, recognizing that there are two types of users. There's a user that might be maintaining the input variables or the configuration of your module. And then there might be users that have to deal with the downstream impacts of the change that your infrastructure as code solution puts out into the environment. One cares about ease of input and readability, and the other cares about unnecessary churn created within the environment. Anyways, what do you think? Do you use this approach within your Terraform projects? I know I was using the Azure AD provider, the Microsoft Entra ID provider today, but these concepts transcend what cloud platform you're using. I know this channel is called the Azure Terraformer because I do spend a lot of time working with Azure, but I hope if you did find your way into my channel and your primary cloud is not Azure, be it AWS or Google Cloud, you can see that these concepts and these patterns are very much applicable within your world. Well, that's it for today. If you enjoyed this video, please smash that like button and consider subscribing to my channel. Also consider channel membership. It really helps out a lot. That's it for me. This is the Azure Terraformer, signing off.